Okay, hello everyone. So I especially like the animation of this slide. It's like used to be Kaggle's default presentation template. Now it's gone, but I still like to use it. So today I'm going to talk about how I started in Kaggle, what were the milestones, how I was able to reach where I stand now, and at the end of the competition talk how I turned the insights, the skills I got in Kaggle into let's see, business problem that I'm trying to solve with my team. So yeah, this is me. As Mila already mentioned, that I'm better at discussions than competitions. So not the first one today. And I come from Lithuania. It's a very small country. There's less than 3 million people. We love basketball. We have a very fast and very cheap internet. Enjoy 4G internet everywhere. Statistics show that we're like most educated nation in Europe. Know the most languages, speak the most languages, and on top of that, our language is like accepted by linguists as the oldest one in Europe. But apart from that, nothing much is going on in Lithuania when it comes to data science. So there's a cool website where you can check how you rank among your country fellows in Kaggle rankings. So there are like less than 10 people competing, or who at least tried to compete in Kaggle. So this is a little bit sad. So when I joined, I was actually the loner and didn't have any like friends in that regard. So my background, I studied econometrics. So econometrics is basically turning time series into differentiated time series and trying to extract some signal from it. I have worked in credit risk scoring for 6 years, where I had the chance to make some interesting models, including using Facebook data. So practically, at some point, we were able to collect most of the Lithuanian profiles into a single database and make some interesting models with that. Sadly, it's not available anymore due to policy changes. And in the last year or two, I've also been doing some consulting work where I delivered machine learning models to the client. So this is my timeline, how I progressed. So I started Kaggling 3 years ago, and I think it's in 5 or 6 weeks I was already a master. Then in less than a year, well, probably in a year's time, I became a Grandmaster. So at that time, I was like the fastest person to reach that title. Yeah, and after some time, I decided that I want to like make something interesting, use skills in the business life. So starting off, I'll just start with my first competition, where my team placed 4th. So as you can imagine, as a newcomer, it's a huge achievement. Not only get a medal, but also get a money prize for that. And as you can see, there were already smart people here competing, and they were like super smart guys, and I was like a complete noob. I didn't know any machine learning at that point. I was building logistic regressions in my work. And when I started doing it, it was like, wow, I know nothing. I was like, how do even people build machine learning models? It was a mystery for me. So why this data set is so special for me? Well, it is one of the hardest data sets, anonymous data sets that I have worked with in my career. So it has about 2,000 anonymous features, over 150K training data, and it is so noisy that it is very hard to like do some feature engineering or or any smart data transformations, and it all leads to like machine learning, trying to optimize like hyperparameters and such. And this competition actually started. I think only a few months have passed since XGBoost was introduced to like machine learning community, and not many people actually knew how to tune this method. So it was still a mystery for most of the Kagglers. And this is how it looked like. So I started like most of you, just took a kernel, applied, ran the kernel and submitted to the leaderboard. Well, it was not good enough. I thought, okay, maybe I should dig into the data. And I spent like 50 hours trying to understand maybe I can actually do some feature engineering and such. And in fact, I was able to find one interesting feature. So it was, I think, postal codes, which were very sparse. So I applied like mean target encoding. And back then, I didn't know how to do it properly. So the model itself was based on overfitted features. And so in 1 month, I decided that, okay, I have a good progress. I'm in the top 10, and then you get a chance to team up with like a top 10 guy in Kaggle, and he invites you to team up. So it was one of the best decisions in my life, and I highly encourage you to do that, especially when you're like starting. And this person, his name is Shiza Su. He has won multiple competitions himself. He introduced me to the world of like blending, stacking. So like 1 month into Kaggle, I didn't know what blending was, what stacking was, and well, everything seemed to be mysterious. And therefore, during that competition, I spent like 15 hours a day trying to learn, trying to understand how machine learning works, how people approach data, how they apply transformations. So in the end, we did pretty okay. We dropped in the private leaderboard, probably due to these badly designed features, but still it was a good experience. And until today, even today, I'm using this data set to test the ideas with like new machine learning models like GBM, CAD-Boost, and such. So it's a very good benchmark to see how the models compare. Moving forward, so on the left, this is the guy I talked about, Shiza Su. He's like my mentor, like inspiration to keep on working in Kaggle. And on the right is the person who made the biggest impact in the way I learned machine learning. So Owen Zhang has many presentations, both PowerPoints and YouTube videos, which are, I think, useful even at today's standards. So I hope that someone will appreciate his input into Kaggle community as well. So during that competition, I learned a few important lessons. So for me, I understood that I have to manage my resources effectively. I didn't have very strong computational resources then, but I knew that I have to write efficient code, use parallelization, and well, just do the best job at the code quality you can. So the next thing that was also important for me, and I also follow this thing even today, work on a single model as long as you can. You can always spend the last 3 or 4 days of the competition to build other models, but as long as you know that you have a strong model, which is okay, doing, let's say, in top 20, 30 or so, you already did a fine job at solving the problem. So I also had this revelation that all the machine learning is just a function approximation of the real world. I've never had this like concept in my mind, and I like this very much. So then we have talk about data tweaking. Sometimes it is good to apply data tweaking, especially when you work with categorical features. So if you're doing like, let's say, label encoding, it might be sometimes smart to reshuffle, let's say, categories in the way that, let's say, target ratio would be like in a zigzag form. So let's say XGBoost would not be like, would not want to group some categories because, well, maybe the separation between categories is also very important, and this actually worked in this competition. And lastly, what was the most interesting, that up to that point I thought, okay, three methods are like perfect approximations of like the data generation, but in fact they are very like sensitive to noise. So if you spend enough time in feature selection, you can achieve as good results as like doing model stacking and such. And this is important, and this is what I do in every Kaggle competition. So then I think this is my, let's say, the best competition I've had in my career. So it was like 2 months into Kaggle, and I already had my best competition that I cannot best today. So why is it so special? First of all, of course, we won the competition, but there are some caveats in that, because in the way we did it is very interesting. So I guess every one of you know the company called H2O. So they used this data set as a benchmark, like how to automate machine learning, just give inputs to the algorithm, to the AutoML platform, and they just spit out the like top 10 result, and it's it's done in 2 hours. And it's also interesting because, well, we actually won the first place doing the things much more simpler. Okay, so this is how the data looked like. Again, very interesting, all floats, some categorical features. So it's very hard to decide where to start. Then I started raising questions. So this is anonymous data. Is it truly anonymous? Categorical features, or maybe interactions are significant, or something like that. Missing values, are they missing at random or not? Evaluation metric, is it aligned to what, let's say, XGBoost has by default? So when you answer these 4 questions, the 2 questions really popped into my mind. So all the features are floats, so it's pretty strange. So how often would you find a data set where you would not find an integer as a column? And what would you do if you had like a sponsor to anonymize the data so that it would be anonymous? Interesting. So what I did, I thought of a way how to de-anonymize the data so that maybe some structure appears in the data. And in fact, it worked well. There were like 2 features. So after like unscaling and meaning and similar operations, there were 2 integer features. And it became pretty obvious that I could sort the data by these integer features. And in fact, these integer features appear to be a timestamp. Maybe a date. And when you try to sort by some specific categorical feature, you find interesting relationships. So for example, in this yellow square, we have V22. So I assumed it was a customer or something of that sort. Then we have V40, which is time. V50 is like time since he became a customer and such. And you can already see that the target has some temporal relationship. So if it's 0, it's very likely that the next observation will be 0. So so having that in mind, you only have to introduce 2 features, lag and lead. Okay, it may not, using lead features, well, is okay, not doing it in a business correct way, but you have to do it in Kaggle anyway. So I used these 2 features and built a simple model. It was a single model, which was that good that it was enough to be in first place throughout all the competition until since we found it. So and this is typically how the competitions look like. So you start with simple models, basic ideas, simple feature engineering, and if you're lucky enough, you find this kind of like trick in the data. And if you're able to find all the tricks in the data, it's a very high chance that you will place high in the competition. And yeah, that's like the third part. So why the difference between first place and second place was not that big, as you would expect, because the teams only did that brute forcing way, building lots of models, lots of feature interactions and such. So trying to make it as an approximation. And my features already captured the real signal. And during that competition, I've met my best friend in Kaggle, and it's very sad that he could not come, but it is very good to have friends in Kaggle, and I really enjoy talking to people, discussing about life, Kaggle and such. So the third competition came just after this one, and this was a sad event that at that time the number one ranking Kaggle member died. And we thought, okay, we could, as a Grandmasters, like top 10 guys, form a team and do a competition in Pneumonia. And it was a very interesting experience because, well, this Santander competition is well, famous for its shakeups and all the crazy stuff in it. So basically what we have is very small data set which is very imbalanced, some noisy features. Then you have AUC metric on top, which is hard to optimize. And there's literally no CV leaderboard correlation. So what we did as a team, we decided, okay, let's use 5-fold cross-validation, but let's repeat it 20 times. So we build we have 20 different cross-validation splits, build the models, and on top of that, each model is also trained 20 times and bagged, so in that sense, averaged predictions. So just to train one model, you had to train 2,000 models. It's interesting, but it works. And here also, I was able to find a killer feature, so just to manipulate the data, try to do some combinations, and one of the combinations I believe represented the binary feature of whether the customer is a new client or existing, and using it as a feature was very strong. And in the last day of the competition, we thought we need to blend lots of models, and AUC is very, well, not convenient metric to do stacking and such, so we just ran everything through Optim. And yeah, we just didn't trust our Optim enough, so we used weights which were more conservative in that regard. And this is the strategy I actually use in all the small data competitions. So Mercedes, where I placed in top 20, NCAA, where I have both top 20 and the first place in a women regard. So this is something that works, and I'm applying it at any time that I meet small data set. And this is the competition where I got my Grandmaster's title. It was one of the worst competitions I have participated in because there was a leak and it was known from like day one, and the organizers did not want to like restart the competition. But the leak was obvious, but how to use the leak information was not so trivial. Okay, so if you look at the leaderboard, so 4 teams have figured something out, and I know that Stanislav figured this out in the last days of the competition as well. So what was the trick? The data was prepared in that way that there were like customers with several, let's say, observations, and the split was not done by a customer. It was random split. So you could actually probe the public leaderboard and get a result which would generalize on private leaderboard. So what I did actually was like last 3 weeks, I only did this kind of submitting, which was pretty much sad. But I knew that this was the winning strategy, and although I felt bad, but I had to do it just to win this competition because I really wanted to get that Grandmaster title. Yeah. So I'll just skip to the next part, so more about my life. So in the last 18 months, I said before, Lithuania is a small country, not many people actually know what's happening in the world when it comes to data science, so I thought that I should do something about that. So I appeared in the radio twice, talked about Kaggle, about how people approach problems in Kaggle, then attended some presentations in some leading companies in the region. Then there was this AI hackathon, where I was happy to be invited as a mentor. Then we have a group of people who are like an initiative group to like spread the idea of like open data and data science open to everyone. So we're like hosting monthly meetups, which like the first one gathered, I think, about 400 people. It just was very unexpected, and the trend stayed in the last year. And now the Kaggle itself has become a very interesting topic. So not only data scientists know what Kaggle is. Sometimes we just meet random people in the street. They just say, "Oh, I know this platform. They're smart guys doing interesting stuff here." And well, it's let's say I feel happy that I was able to achieve it in such a short time. And lately, we're like thinking of finding the Lithuanian AI Association, inviting all the companies in the country, and yeah, this is it. So during one of those presentations in local companies, there is this company called Neuro Technology. It's a biometrics company which has the fastest and the most accurate fingerprint detection algorithm in the world. And these guys were like inspired by me just to try the competitions out and maybe try to use their skills in this fashion. And what they did was out of the world. So like first and second teams are the guys from this company, so their score is pretty close. Also, they worked independently. But when you look further down the leaderboard, so from log loss perspective, the difference was very astonishing. And these guys knew how to do stuff. They have been working with deep learning for a while. So after this competition, they invited me to join the other deep learning competition. So we teamed up with 7 days remaining, and the design of the competition was very similar to the previous one, but it required a very important element, that you had to manually annotate the images. So imagine looking at 10,000 cancer images, which with lots of blood and such, and you have to like do the bounding box thing, just so that you just could use detection frameworks. And yeah, this is what we did. We also made the pipeline so that when you get the stage 2 data, you could reuse the stage 1 labels, and this is perfectly fine, not against the rules. And again, the results were quite interesting. So at that point, we understood, okay, we have skills and knowledge, and during the hackathon, we found a radiologist who's very interested in AI, and he's like has done deep learning for a while himself. So he just suggested that let's make something interesting, something that could potentially change the world. Okay, this slide is not too relevant, but yeah, this one. So we founded the company like almost 2 years ago, and what our goal is, okay, we have medical imaging problem where we have doctors looking at the images and they try to write something what is wrong and maybe what is right with the chest X-ray. And there are millions of data available in many hospitals, and actually it is the most frequent medical imaging done in hospitals. It's over 50% of medical imaging is chest X-rays. So we thought, okay, we kind of have access to local hospital data. We have a know-how, and why not do it? So we have building such a solution that you have an image, and using a deep learning predicted labels, you automatically generate a report, and we like a template for a radiologist. So as soon as he opens the, let's say, X-ray, he can already see pre-generated report, and if he likes it, he can actually accept it and, well, save time and such. Yeah, so this is the part where we have this like small web application where we try to visualize the predictions. It's not too relevant. The UI experience is not something that is important for this task. But we have a classifier which predicts 76 different findings. So it's like heart diseases, lung diseases, bone problems, various devices, and such. But the problem was not the images, but the radiology reports, the retrospective reports, where you have to do text mining. So the reports themselves are like free text, and you have to think of a way how to extract those 76 classes with least error that you can make. So this was the hardest part. So when you solve the labeling part, we have worked on like experimenting, choosing the right architectures and such. So in the end, we were able to achieve decent score. So it's 0.93. It's good, and when you compare to, let's say, archive papers working on public data, this score is higher than, let's say, state of the art. And the thing is, we would like to solve it as this problem as a detection problem, but the problem is that you would have to hire radiologists to do all the bounding box thing. So as you can imagine, it's a very expensive process. So when you compare it to, let's say, self-driving cars doing the instant segmentation of roads, buildings and such, so you could use like mechanical Turk to annotate your data, but it is very expensive to do it in this setting. And okay, we have a classifier, but when you go to the hospital and say, well, we have a cool stuff, it does cool stuff, but the doctors want to understand why the model said one thing and not the other thing. So we have been using some class activation maps, and this is a good selling point because, well, you can actually say, well, based on the upper regions, we decided it's tuberculosis, and this is correct in this case. So in general, building models is a much easier task than actually trying to sell. And this is one of the experiences that I underestimated when we started doing that. And okay, so it's almost the last slide. So what are these class activation maps? So why we are able to like visualize the outputs of a classifier, not a detector. So let's say we have an input image with some labels. We have inception inception with 3 network. So this is actually what we're using as well. Then you take the last convolutional layer where you have 192 class activation, neural network activation maps, and then the next layer is like a mean pooling layer, and after a mean pooling layer you have a fully connected layer to the prediction layer. And you actually can combine the information from convolution layer images with mean pooling weight vector to actually do the weighted averaging based on the specific pathology signal in the prediction layer. And this is how it's actually done. And finally, let's say we have mean pooling layer, so it's like second from the right. We thought, okay, this is also very useful information. Why we do not build a like index, like a search index for X-rays, just by using these kind of vectors. And this is something that actually works. So you just have a database, save the vector information in like a CSV file or a database file, and do, say, you have a new image, you calculate these vectors, do some distance calculations, and like report top 10 most similar cases. And this is where things got interesting. So we have a classifier which is able to predict 76 classes, but of course there are very rare cases which you just cannot get enough data to cover to actually build a class for that. And when you use that rare disease image as a search object, we found out that in top 3 search results, you would actually find this pathology in the database. So you haven't trained a network to recognize something, but it is able to find similar images in that regard, and this is very useful. Yeah, so the last competition there was already a presentation about Pneumonia, so we also participated as a team. We spent quite some time on that, but we did a very big mistake, which is very sad. So we did not read the rules, well, not the rules, but the description of the competition, where it was clearly stated that test set is from different test set images are coming from different distribution, and if we actually had done something about it in the beginning, I estimated, well, tested that we would have at least at 3rd place. So again, this is a good validation that we are at least doing something at the top level, and there's still something that we are good at. Yeah, so I want to conclude my presentation with this interesting quote from actually Warren Buffett talking with Bill Gates about how they manage their time. And Warren Buffett has this like calendar of like things he has to do, and it's actually pretty empty. And he said that like time is something that you cannot buy, and this is, I think it is relevant for Kaggle because, well, you cannot spend too much time on Kaggle if you just can't. And managing your time, especially during like when you actually can do something, can compete in Kaggle, is very important. And this is something that also is relevant for me because, well, I started from doing a 15-hour a day like learning to like spending 4 to 6 hours of my time a week now. So I guess I have to pick the competitions that I like the most and only focus on those. Yeah. Thank you.
Thank you very much, Darius. Any questions? Yeah.
So many questions. Okay, so you are a startup founder, and so I'm curious for this question. So what do you think about if somebody told you, hey, I'm going to get this first place solution that somebody published the code of in Kaggle. I'm going to get this code. I want to build a startup out of that code. How far is somebody who has a very good code for a Kaggle competition to really start a startup? Should he do it? Is a totally different story, the real world.
So our startup was not based on the code we had. We had the idea that we can do good stuff.
I know.
So just by having a good code does not make you like a good idea to make a startup. There are some questions about like market, business, how are you going to sell? These are, I think, even more important questions when it comes to like data science.
Thank you.
Any questions more?
No?
Okay. Thank you very much, Darius.